next point from the topic triangle is very important point, that is Pythagoras theorem and converse of Pythagoras theorem. So first of all we will see the Pythagoras theorem. We know that Pythagoras theorem is applied to only right angle triangle. It is not applicable for any other triangle. It is only applicable for right angle triangle. And it states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides of the triangle. Here the statement of the theorem is that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Here ABC is a right angle triangle and it is right angle at B, means angle B is equal to 90 degree. Here angle B is 90 degree. So to prove this theorem, first of all we will write given, means the information of the figure. Here triangle ABC is a right angled triangle and angle B is equal to 90 degree. Angle B is equal to 90 degree. To prove that, what is our proof? Means the sum of the square of the hypotenuse. If B is the 90 degree, then its opposite side, that is AC. AC is the hypotenuse. So square of the hypotenuse is AC square. AC square is or is equal to the sum of the squares. The sum of the squares of the other two sides. Which are the other two sides? AB and BC, means AB square plus BC square, and therefore AC square is equal to AB square plus BC square. So we have to prove that AC square is equal to AB square plus BC square. Here we look a construction that from point B draw perpendicular BD to AC, to side AC. Here construction from B draw BD perpendicular to AC, and now we will see proof. Here due to the perpendicular, our original triangle ABC is divided into two more triangles, means triangle ADB and triangle CDB, and our original triangle is ABC, means in all there are three triangles. First ADB, then BDC, then ABC. So we have to prove that these three triangles are similar to each other. Means first of all we have to prove that triangle ADB is similar to triangle ABC, and the another proof will be triangle CDB similar to triangle ABC. So first of all we will see in a triangle ADB and triangle ABC, in a triangle ADB and in a triangle ABC. So here we know that in a triangle ADB it is a right angle, and in a triangle ABC B is the right angle. So these two angles means angle ADB equal to angle ABC, and reason is each 90 degree. Now here angle A of triangle ADB and triangle A of triangle ABC, that is A is common angle, and therefore angle A equal to angle A, reason is common angle, and therefore we know that if the two angles of one triangle are equal to corresponding two angles of another triangle, then both the triangles are similar according to AA criteria, and therefore triangle ABC, ADB, similar triangle ABC, that is AA criteria. Now we know that if both the triangles are similar, then corresponding sides are proportional, means AD upon AB is equal to DB upon BC is equal to AB upon AC, AB upon AC. Now here we got three ratios, but out of two ratios we have to select. Which two? Means the same, that is here AB is there and here also AB is there. These two ratios we have to select, means AD upon AB is equal to AB upon AC. Now AB into AB, if we cross multiply, then we get AB square is equal to AD into AC. So AB square is equal to AD into AC, and that is our equation number 1. Now we have to consider the second triangle, that is triangle BDC, BDC, and our original triangle ABC. So in a triangle BDC and a triangle ABC, we know that in a triangle BDC again angle D is 90, and in a triangle ABC angle B is 90. So angle BDC equal to angle ABC, each 90 degree. Similarly here C of angle C of triangle BDC and angle C of triangle ABC, that is common angle, and therefore angle C equal to angle C, that is common angle, and therefore by AA criteria triangle BDC similar triangle ABC. So these two triangles we have proved that these two triangles are similar. Now if the two triangles are similar, then we will get corresponding sides are proportional, means BD upon AD, BD upon AB is equal to BC upon BC and BC upon AC. Here BC upon AC. But here out of three ratios, we have to select only two, means BC and BC are there. So take these two ratios, and BC upon BC is equal to BC upon AC. If we cross multiply BC into BC, it will be BC square is equal to AC into DC, equation number 2. And now adding equations 1 and 2, we get here equation 1 is AB square, and means LHS of equation 1 is AB square and LHS of equation 2 is BC square. So we will get AB square plus BC square, AB square plus BC square. Then RHS of equation 1 is AD into AC, AD into AC plus RHS of 2 is AC into DC. Here we can take AC as a common, AC into bracket AD plus DC. Now if we consider the figure AD plus BC, and that is equal to AC. So AD plus BC is equal to AC. So AC into AC, that is equal to AC square. In this way, AB square plus BC square is equal to AC square. Means this theorem states that the sum square of the hypotenuse is AC. Square of the hypotenuse is equal to sum of the squares of the other two sides AB and BC. In this way, we have proved the Pythagoras theorem. Now we have to see the converse of Pythagoras theorem. Converse of Pythagoras theorem. Here the theorem states that in a triangle, means any triangle, it is not a right angle triangle, it is any triangle. In a triangle, if the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the side is a right angle. Means we have to prove that if such a condition is satisfied, means if the square of one side is equal to sum of the squares of the remaining two sides or other two sides, then side opposite to first side, our one side means first side, is means the angle opposite to one side of the side is a right angle, means triangle ABC is a right angle triangle. So we have to prove that triangle ABC, our ABC is a right angle triangle. Here ABC is a triangle, any triangle that is not right angle triangle, any triangle, and we have there is construction. So before explaining about the construction, we will write given. Given means explanation of the figure. So in a triangle ABC, it is given that square of one side means AC square is equal to sum of the squares of the remaining two sides or other two sides, means AB square plus BC square. So it is given. So according to this statement, we have written the given. Now to prove angle B is equal to 90 degree or triangle ABC is a right angle triangle. So this is our proof. Here I have not written proof, but proof is that angle B is equal to 90 degree or triangle ABC is a right angle triangle. So construction is draw a triangle DEF. Another triangle we have to draw here, that is DEF, and we have to construct DEF, triangle DEF in such a way that DE is equal to AB, means length of DE is equal to AB. Then EF is equal to BC, length of EF is equal to BC, and angle E is equal to 90 degree. In this way or in such a manner, we have to construct the another triangle DEF. And now we will write the proof. In order to prove that angle B is equal to 90 degree, means we have to prove that angle B is equal to 90 degree, then and then it will be a right angle triangle. So to prove that angle B is equal to 90 degree, it is sufficient to show that these two triangles, means triangle ABC and triangle DEF, are similar. Because if both the triangles are similar, then corresponding angles are equal. Means angle E equal to angle B. But we know that angle E is 90, so angle B must be 90. In this way, first we have to prove that both the triangles are similar. So in a triangle DEF, angle E is equal to 90 degree, means DEF is a right angle triangle, and we know that the Pythagoras theorem is only applicable to right angle triangle, and therefore we can apply here by Pythagoras theorem. We can write that DF square is equal to DE square plus EF square. So DF square is equal to DE square plus EF square. But we know that here in the construction DE is equal to AB, so instead of DE I have written here AB square plus EF, instead of EF we know that EF is equal to BC, so instead of EF we will write here BC, so it will be BC square, means DF square is equal to AB square plus BC square. Now this is our equation number 1, and we know that in a given, it is given that AC square is equal to AB square plus BC square. So AC square is equal to AB square plus BC square. Now from these two equations, both RHS are equal, and therefore LHS must be equal. Means BF square is equal to AC square. That is, taking square root on both sides, we get DF is equal to AC. DF is equal to AC, and that is equation number 2. That is our equation number 2. And now we will take these two triangles, that is inner triangle ABC and triangle DEF. Inner triangle ABC and the triangle DEF. We know that AB is equal to D, then BC is equal to EF according to construction. Means AB and DE are equal, then BC and EF are also equal, and AC is equal to DF. From equation 2 we can write AC is equal to DF. Means here it is seen that all the three sides of one triangle are equal to corresponding three sides of the another triangle, and therefore both the triangles are similar to each other. And by yes criteria, here if both the triangles are similar, then corresponding angles must be equal. Means angle E equal to angle B, but angle E is given 90 degree, and therefore angle B is also 90 degree. And if angle B is 90 degree, then triangle ABC is a right angled triangle. So these are the two very important theorems for the point of our examination. So we have to study it well. We have to see some important result based on Pythagoras theorem. Means yesterday we have seen the Pythagoras theorem as well as converse of the Pythagoras theorem. If the square of or inner right angle triangle, the square of one side is equal to sum of the squares of the remaining two sides, and the converse of the Pythagoras theorem is that if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the angle opposite to the side is a right angle. Means the triangle is a right angle triangle. So we have to see some results based upon the Pythagoras theorem. The first theorem, that is the result on obtuse angle triangle. The result on obtuse angle triangle. Here triangle ABC is obtuse angle triangle, and it is obtuse angled at B. Means angle B is an obtuse angle. This theorem states that in the figure, triangle ABC is an obtuse triangle, obtuse angled at B, and if AD is a perpendicular to BC, AD is a perpendicular to BC, then we have to prove that AC square is equal to AB square plus BC square plus 2BC into BD. Here it is seen that AC means the side opposite to the obtuse angle, and square of the side opposite to obtuse angle is equal to the sum of the squares of other two sides. Means AC square is equal to AB square plus BC square plus twice of the product of one side and projection of other on first. Projection, here the perpendicular drawn AD and the line segment, if we produce the side BC to D and draw the perpendicular, then BD is called as projection. BD is called as projection on projection of AB. This is the projection of AB, and we have to prove here that AC square is equal to AB square. AC square is equal to AB square plus BC square plus 2 BC into BD. BC into BD. So to prove this theorem, we have to write given means the information of the figure. Here triangle ABC is an obtuse angle triangle. Obtuse angle at B. AD is perpendicular to CD. AD is perpendicular to CD, and therefore to prove AC square is equal to AB square plus BC square plus 2BC into BD. Proof, triangle ADB. Here triangle ADB. This is a right angle triangle, and if it is a right angle triangle, then we can apply Pythagoras theorem, and therefore by Pythagoras theorem we can write AB square means hypotenuse square is equal to AD square plus DB square, or side 1 square plus side 2 square, or sum of the squares of the two legs. Here equation number 1, AB square is equal to AD square plus DB square is equation number 1. Now triangle ADC again is a right angle triangle. Here ABC means we have to consider the larger right angle triangle here, and again we have to apply Pythagoras theorem. Then we will get AC square is equal to AD square plus BC square. AD square plus BC square. Here write AC square and AD square as it is. There is some change, that is we have to substitute the value of BC. Here BC means total, means DB plus BC. Here so DC is equal to DB plus BC bracket square. Here again we have to apply here the identity, that is A plus B bracket square. So A square plus 2AB plus B square means DB is A, BC is B. A plus B means DB square plus BC square plus 2DB into BC. So AC square is equal to AD square plus DB square plus BC square plus 2DB into BC. And now here from the equation 1, AD square plus DB square means AD square plus DB square we have to combine here, so that we can substitute the value of this bracket, that is AD square plus DB square is equal to AD square. So we have to combine AD square plus DB square into bracket, and remaining terms outside the bracket we can write, so that we will get AC square is equal to into bracket AD square plus DB square plus 2BC square plus 2BC into BD. Here from equation 1, AD square plus DB square is AB square. So AC square is equal to AB square plus BC square plus 2BC into BD. So that is from equation 1, where here BD is known as projection of AB on BC. Projection of AB. Projection of AB on BC. Means the theorem can be stated as in an obtuse angle triangle, the square of the side opposite to obtuse angle is equal to the sum of the squares of the other two sides plus twice the product of one side and projection of other on first. In this way, we have seen the result on obtuse triangle, and now we have to see the result on acute angle triangle. Here, result on acute angle triangle. Here, triangle ABC. Here also it was triangle ABC, and this is also triangle ABC, in which angle B is an acute angle. Acute angle means less than 90 degree. So angle B is acute angle. The theorem is given in the figure. Angle B of triangle ABC is an acute angle, and AD is perpendicular to BC. Is from AD is drawn perpendicular to BC. Then prove that AC square means side opposite to B, acute angle, is AC. AC square is equal to AB square plus BC square minus 2BC into BD. 2BC into BD. So we will prove now. Given is triangle ABC is an acute angle triangle, angle B is an acute angle, and AD perpendicular to BC. So first of all, we will consider the first right angle triangle, that is triangle ABD or ABD, whatever it may be. So triangle ADB is a right angle triangle. Angle ABD is equal to 90 degree, and therefore by Pythagoras theorem we can write AB square is equal to AD square plus BD square. So that is equation number 1. Also, triangle ABC is also a right angle triangle, so we can apply Pythagoras theorem here, and therefore AC square we can write here AC square is equal to AD square plus BC square. But we can write here DC means B between S, D between S, C, and therefore BD plus DC, that is equal to BC, BD plus, and therefore we can write here DC is equal to BC minus BD, BC minus BD here, and therefore DC is equal to BC minus BD. We can substitute this value here. We can expand this bracket by the identity A minus B bracket square, means A square minus 2AB plus B square. So AC square is equal to AD square as it is here, BC square plus BD square minus 2BC into BD. Again here we have to combine the terms AD square plus BD square. From this AD square plus BD square, we have to combine these two terms into a bracket. So AD square plus BD square bracket complete plus BC square minus 2BC into BD. Here we have to substitute the value of AD square plus BD square, and that is AB square. So we can write here AC square is equal to AB square, the value of this bracket, plus BC square minus 2BC into BD. We can write from equation 1, and here BD is again known as the projection of AB on BC. So this theorem can be stated in another word, that is in an acute triangle the square of the side opposite to an acute angle is equal to the sum of the squares of other two sides minus twice the product of one side and the projection of other on first. In this way we have seen these are two results, that is the result on obtuse angle as well as the result on acute angle. Now, dependent upon these two results, we have to see one more theorem, and that is known as Apollonius theorem. That is known as Apollonius theorem. We have to see some theorems or important results which are based upon Pythagoras theorems. Two theorems we have seen, that is property of acute angle and property of obtuse angle. So these two properties we have seen, and now related to these two properties we have to see one more property, that is known as Apollonius theorem, or it is known as midpoint theorem. Its one more name is Pappus theorem. So here ABC is a triangle in which, if we draw this triangle, ABC, and if we draw a median, that is AD, then the triangle ABC is divided into two parts, that is triangle ABD, which is obtuse angle triangle, because angle ABB is obtuse angle. So this angle is divided into, that is triangle ABC is divided into two triangles, out of which one is obtuse angle triangle, that is ADB or ABD is obtuse angle triangle, and the another one, that is triangle ABC, is acute angle triangle. Here AD is a median, and due to this median ADB is obtuse angle triangle, while the another triangle, that is ADC is an acute angle theorem. And now through point A or vertex A, draw AE perpendicular to BC. Draw AE perpendicular to BC. In this way, first of all, we understood the figure, and now we will see the theorem, that is Apollonius theorem. Here, the sum of the squares, of any two sides is equal to twice the square of half of the third side together with twice the square of the median which bisect the third side. Means here we have to prove that AB square plus AC square is equal to twice of median, that is 2AD square plus 2BD square, 2BD square, or we can write AD square plus AC square is equal to 2AD square plus 2 into bracket 1 upon 2 BC square, because 1 upon 2 BC is half of BC is BD. Here instead we can write BD, we can write here 1 half BC, 1 half BC. So to prove AD square plus BC square is equal to 2 into AD square plus BD square. Here first of all we will see that given in a triangle ABC, AD is the median. Means first of all we have to remember that the Apollonius theorem is applied only when the median of the triangle is given. Only when the median of the triangle is given. And now here to prove AB square plus BC square, AB square plus BC square is equal to 2 twice of median square, means 2 into AD square, 2 into AD square plus 2 into BD square, 2 into BD square or 2 into bracket AD square plus BD square we can write. Here construction, draw AE perpendicular to DC. लक्षात ठेवा या ठिकाणी आपल्याला BD कसा लिहिता येतो, तर BD is equal to 1 half BC, 1 half BC असं लिहिता येतो. कारण तुम्हाला माहिती आहे की AD ही काय आहे, मीडियन आहे. मीडियन जर असेल तर D हा मिड पॉइंट झाला आणि मिड पॉइंट जर असेल तर BD ची व्हॅल्यू किती असणार आहे, तर BC च्या 1 half असणार आहे. So BD is equal to 1 half BC. So we can write here that AB square plus BC square is equal to 2 into AD square, 2 into AD square plus 2 into BD square, 2 into BD, but BD is 1 half BC bracket square. So in this way we can write. Now we will see the proof of this theorem, that is triangle ADB is an obtuse angle triangle. Here I have just now explained that triangle ADB is an obtuse angle triangle, and therefore by result of obtuse angle triangle we know that the side opposite to obtuse angle is AB square. So AB square is equal to AD square plus BD square. AB square plus here AD square plus BD square, because we have to consider only this triangle and side opposite to obtuse angle is AB. So AB square is equal to AD square plus BD square, AD square plus BD square plus 2BD into D, 2BD into D, because here BD into D, here D is, because we have drawn here D is the projection, D is the projection of AD on BD. So here AD square is equal to AD square plus BD square plus 2BD into D, that is equation number 1. And now we will consider the another triangle, that is triangle ABC, and this is acute angle triangle. Here acute angle is at D, and therefore we have to consider the side opposite to acute angle is AC. So AC square is equal to AD square plus DE square. Here AC square is equal to AD square plus DC square minus 2DC into D, 2DC into D, and that is, here we know that D is the midpoint of BC, D is the midpoint of BC, and therefore DC equal to DD. Here DC equal to DD, and therefore from these two DC we have to remove these two DC and substitute their BD. So we will get here AC square is equal to AD square plus BD square minus 2BD into D. लक्षात ठेवा की या ठिकाणी आपल्याला काय की D हा मिड पॉइंट आहे. जर मिड पॉइंट असेल तर DC ची लेंथ आणि BD ची लेंथ कशी असणार आहे, इक्वल असेल, and therefore DC is equal to BD. आता याच्यामधले जे DC आहे ते काढून टाका. यामधले DC काढून टाकल्यानंतर आपल्याला काय मिळेल, DC काढून टाका आणि त्याची व्हॅल्यू काय आहे BD, ती भरल्यानंतर आपल्याला मिळेल AC square is equal to AD square plus BD square minus 2BD into DE, and this is equation number 2. Now adding equation 1 and 2 means LHS of first is AB square and LHS of 2 is AC square. So AB square plus AC square we get here. RHS of 1 is AD square plus BD square plus 2BD into DE. AD square plus BD square plus 2BD into DE. Then plus RHS of second equation is AD square plus BD square minus 2BD into DE. So AD square plus BD square minus 2BD into DC. Here 2BD and 2BD DC DE, it will get cancelled. It will get cancelled, and then we will get here AB square plus AC square is equal to 2AD square plus 2BD square, and therefore if we get 2 as a common, then we will get the equation AB square plus AC square is equal to 2 into bracket AD square plus BD square. So in this way our theorem, Apollonius theorem, we have derived here, and now we will see the question or another theorem. Prove that 3 times the sum of the squares, 3 times the sum of the squares of the side of a triangle is equal to 4 times the sum of the squares of the median of the triangle. Means 3 into AB square plus BC square plus AC square, sum of the squares of the sides are AB, BC and AC. So 3 into AB square plus BC square plus AC square is equal to the 4 times the sum of the squares of the median of a triangle. Medians are AD, B and CF. So 4 into bracket AD square plus BE square plus CF square. So here ABC is a triangle, and AD, B and CF, these are the medians, and here we have to apply the Apollonius theorem, and then we can prove this theorem. Now here given in a triangle ABC, AD, B and C are the 3 medians on this side, BC, AC and AD respectively. To prove 3 into bracket AB square plus BC square plus CS square is equal to 4 into bracket AD square plus BE square plus CF square. And now we will see proof. We know that the sum of the squares of any two sides is equal to twice the square of half of the third side together with twice the square of the median bisecting it. Means here the Apollonius theorem is given here, and according to Apollonius theorem, if median is given, then we can write taking AD as the median. Here AD is the median, bisecting this side BC, then we will get here AD square plus AC square is equal to 2AD square plus 2BD square, or 2 into bracket AD plus BD bracket square. Now we know that BD is half of BC. BD is half of BC, means BC upon 2. So 2 here AB square plus AC square is equal to 2 into AD square plus BC upon 2 bracket square. Again we can write here AB square plus AC square is equal to 2 as it is, AD square as it is, BC square is square of BC is BC square, and square of 2 is 4, so BC square upon 4. Again AB square plus AC square as it is. Now multiply the bracket by 2, so we will get here 2AD square upon 1 plus 2 into BC square upon 4, 2 into BC square upon 4. Here we can reduce 2 1s are 2 and 2 2s are. So we will get here 2AD square plus BC square upon 2. Here AD square plus AC square is equal to. Now for the addition, denominators are not same here, so we have to cross multiply. So 2 2s are 4AD square plus 1 into BC, so it will be BC square divided by 2 into 1, it will be 2. So here 2 is divided, it will multiply at the LHS. So 2 into AB square plus AC square, that is equal to 4AD square plus BC square, and that is equation number 1. So if we consider the median AD, then we will get equation number 1. Now if we consider the medians DE and CF, here similarly by taking DE and CF respectively as the medians, we get here 2 into bracket AB square plus BC square is equal to 4BE square plus AC square, that is equation number 2. And similarly by taking CF as a median, we get here 2 into bracket AC square plus BC square, that is equal to 4CF square plus AB square, and that is equation number 3. Adding equation 1, 2 and 3, we get here 1 means 2AB square plus 2AC square, then 2AB square, here 2AB square plus 2AB square, it will be 4AB square. So 4AB square, 4BC square plus 4CA square. So I have taken directly 4 as a common, and AB square plus BC square plus AC square is equal to here 4AB square, 4BE square and 4CF square. Again here AD square, BE square and CF square I have taken written in the bracket, and 4 is taken as a common. Plus here if we see, then we will get AD square plus BC square plus AC square, and these terms are written in the separate bracket, that is AD square plus BC square plus CA square. And now this is 1, and if we take it to the LHS, then 4 minus 1, it will be 3. So 3 into AB square plus BC square plus AC square is equal to 4 into bracket AD square plus BE square plus CF square. In this way, we have seen all the theorems which are related or based upon Pythagoras theorem, and these theorems are very important for the point of our examination.